Alright, once again we are now looking at the video for section 3.2, which is the basic terms of probability. This is another section that's pretty short and hopefully pretty easy. First, we need to go over some basic probability terms. An experiment is a process by which an observation or outcome is obtained. So the experiment is what you're actually doing. So if you're rolling a dice or picking a card. The outcome is all of the possibilities, what could happen. So if you're rolling a dice, the outcomes are 1 through 6. The sample space is the set S of all possible outcomes. So you just take all your outcomes, you put them in a little curly brace to make them a set. And we always call the sample space capital S. So we learned back in section 2.1 that sets are always described by capital letters, and we try to use a capital letter that means something. So sample space, we use S. An event is any subset E of the sample space S. So an event doesn't have to be called E. It can be called whatever you want it to be called. So if you're looking at the even numbers, you can call it E. If you're looking at the odd numbers, you can call it O. And then they note here that the sample space really means the same thing as universal set. The only distinction between the two ideas is that the sample space is used when you're talking about probabilities, and universal set is used in any situation in which sets are being used. So when you get to your next class, which is probably statistics, they will talk again about the sample space. And really that's the same thing as the universal set, but just in probability we call it sample space. Let's look at an example of an experiment, and then we'll determine the outcomes, the sample space, and then a certain event. It says, suppose you roll a single die. Find each of the following. And the experiment, the outcomes, the sample space, and then we have to find out what is the event of rolling an even number. So like I said, the experiment is what you're actually doing. So this is the process by which an observation or outcome is obtained. So the experiment is where we actually roll the die. You could also say roll a single die. It's really, the wording is up to you. The wording does not have to be specific, rolling the die. Next, we have to find the outcomes. So when you roll a single die, the outcomes are going to be 1, 2, 3, 4, 5, and 6. Next, we have to find the sample space. The sample space is the set of all possible outcomes of an experiment. So you just take all those outcomes 1 to 6 and then put them in little curly braces and then name them S for sample space. And then last we have what is the event of rolling an even number. So once again, an event is just a subset of the sample space S. So you're looking within the sample space S, looking for all the even numbers. So that's 2, 4, and 6. So the event of rolling an even number, I'm calling it E for evens. E is 2, 4, and 6. A couple of more probability terms that you have to know. A certain event is an event that is certain to happen. So it's something that is 100% of the time always going to happen. It is an event that's equal to the sample space S. And then very important, people always forget this definition right here. An impossible event is an event that cannot happen. It is an event that is equal to the empty set. All right, so an impossible event is an event that cannot happen. So for example, if you rolled a die and I asked what is the probability that you roll an 8, you would say that is an impossible event. You cannot roll an 8 if you have rolled a dice or a die. Now let's look at probability and odds. The probability of an event is the measure of the likelihood that the event will occur. We'll only be looking at experiments that have equally likely outcomes. So for example, if you roll a single die, the outcomes are equally likely. That means you're just as likely to roll a 2 as you are to roll a 6. So everyone has a probability of 1 out of 6. 1/6 is the probability of rolling any number on the die. Very important here, make sure you write this down. Probability can be thought of as success over total. All right, so it's written as a fraction most of the time. Sometimes you'll write it as a decimal. All right, so it's thought of as success over total. Let's look at an example. This is straight off of the homework, section 3.2 homework problem number 1. It says, a jar on your desk contains 11 black, 9 red, 12 yellow, and 2 green jelly beans. You pick a jelly bean without looking. Find the probability that it is red or yellow. Alright, so first thing we need to do is think about what probability is. Probability is success over total. Here, success means we draw or we pick up a red or a yellow jelly bean. So success is going to be the number of red or yellow jelly beans that are in the jar. The total is going to be the total number of jelly beans that are in the jar. All right, so let's count up the success part. This is the number of red and yellow jelly beans. All right, so there are 9 red and 12 yellow jelly beans. All right, so that tells us there's going to be 21 red or yellow because 9 plus 12 is 21. Now for the total number, here you need to add up all of the jelly beans. So that's 11 plus 9, that's 20, plus 12, that's 32, plus 2 is 34. All right, so we said that's 12 over 34. So probability as a reduced fraction is 21. Oh, I'm sorry, I said 12. 21 over 34. 9 plus 12 is 21. Okay. What that means as a reduced fraction is you want to check and see if there's any number that goes into the numerator and the denominator. Is there any number that goes into 6 evenly and 34? No. 3 goes into 21, but it doesn't go into 34. 2 goes into 34, but it doesn't go into 21. Alright, so you're done. And then lastly, I ask you to write the probability as a percent and then round it to the nearest 1%. Alright, so I'm going to show you how to do that. So you're going to take your fraction and put it in your calculator and make it into a decimal. So 21 over 34 comes out to 0.6176. It's got a bunch of numbers after that, but I just went ahead and stopped right there. Now, our next job that we have to do is to turn this into a percent. And the way that you do that is you move the decimal to the right 2 times. So take your little decimal point that's in front of the 6. We're going to move it to the right 1 place and then 1 more place. So always move the decimal to the right 2 times if you're turning a fraction into a percentage. Alright, so that turns it into 61.76%. It says to round to the nearest whole number, the nearest 1%. So 61.76 is approximately 62%. Notice that they've already got the percentage symbol in there for you, so you don't need to put the percent symbol in there. You only need to write the number. Now we need to talk about odds. A lot of people use the words probability and odds interchangeably, but the words have different meanings. The odds in favor of an event are the number of ways that the event can occur compared to the number of ways that the event can fail to occur. Simplified, this is odds are success compared to failure. All right, and then this is the way that we're going to write odds. Odds can be thought of as success and then a little colon, failure. Success and then the little colon, failure. And this is just the colon button that's on your keyboard. Alright, so the way that we read this is success and then the little colon, we read that as compared to. So success compared to failure. Now this is different than probability. Remember, that was success divided by total. So here we have success compared to failure. To figure out the total, you would have to add the successes plus the failures. Now let's look at an example with odds. This is straight off of the homework, section 3.2 homework, problem number 3. Again, the words that are in the words that are in red may be different on your homework, so don't put in this exact same answer. just use this as a guide for how to do your problem. A jar on your desk contains 12 black, 9 red, 9 yellow, and 5 green jelly beans. You pick a jelly bean without looking. Find the odds of picking a black jelly bean. Right, so once again, recall that odds are success compared to failure. So what is success here? Success is going to be if we pick a black jelly bean. So this is going to be the number of black jelly beans that are in the jar. Failure is going to be all of the other jelly beans. So you're going to add up all of the other jelly beans that are not black. Right, so not the total. This is just the number of all other jelly beans besides black. Alright, so the number of black jelly beans, that's easy. There's 12. For the number of all other jelly beans, we're going to have to add up these three numbers. 9 plus 9 plus 5. So 9 plus 9 is 18, plus another 5 is 23. So the odds of picking a black jelly bean is 12 compared to 23. So once again, 12 is the number of successes. This is the number of black jelly beans. 23 is the number of all other jelly beans. Here's our last homework problem that we're going to go through, and then I have to mention a definition really quickly, and then we'll be done. This is problem number 4 from the homework, and people always struggle with this one for some reason, even though it's a really easy problem. It says, suppose the table below gives the lifetime odds of death from selected causes, and use it to answer the following question. So it goes all the way from heart disease, which is 1 compared to 6. So 1 out of every 6, or excuse me, 1 person will die compared to 6 people living. Alright, it goes all the way down to lightning. So you can see it's really rare to be struck by lightning. 1 compared to 126, 156. Alright, so it says, what is the probability? What is the probability that a person will die from lightning? Write your answer as a fraction. Alright, the table is telling us odds. This question is asking for probability. So we're going to have to convert these odds into a probability. Here we have the odds of dying from lightning. Success compared to failure. So the success is 1, the failure is 126,156. Since we're looking for probability, we know that probability is success over total. So the success is going to stay the same. That's going to be 1. The total, we're going to have to add up success plus failure. So that's going to be 1 plus 126,156. All right, so again, success stays the same. The success here was 1. And then total is going to be the successes plus the failures. So 1 plus 126,156. All right, so just add up the denominator. And there's our probability, 1 over 126,157. Our last definition that we need to go through, we're not going to use this on the homework in this section, but we will have to use this. I'm pretty sure it's in chapter 4 that we start using this definition. So in the next unit, relative frequency. If you repeat an experiment a number of times and count how frequently a particular outcome occurs, then the relative frequency of that outcome is. Relative frequency is equal to the number of times the outcome occurs divided by the total number of repetitions. So the way that I like to shorten this is I'll say relative frequency is the frequency divided by the total. Alright, so frequency divided by total. Frequency means the same thing as number of times the outcome occurs. So that makes it a little bit easier to remember and a little bit shorter. That's everything for this video. If you have any questions, don't forget to email me, or you can post in the coffee shop Q&A section of our discussion board on D2L.